Welcome to College Mentors Live at Illinois State University. The Physics Club is going to take you through 3 science experiments. We hope you enjoy the video.
Alright. As of now, as you can see, this has an angular momentum of down. How we know that is we curl our fingers in the direction the things are moving. So we curl our fingers, and wherever our thumb is pointing is where the momentum is. So right now we have a momentum of -1. It's going clockwise, so it's -1. Brighton is going to turn it around, shifting the momentum up to +1 as well. So now afterwards, the wheel has a momentum of +1. But notice how Brighton is going the other way. Just spin it back. So right now, Brighton is spinning counterclockwise, so his momentum is up. But you can see that before we have a total of 0. So Brighton is spinning the other way. So now, again, the wheel has momentum going up. Brighton is spinning the other way now. So Brighton is going as a -1 momentum. So as you can see, momentum has to be conserved. So it's -1, +1, 0, +1, -1, 0, which is why he turns the other way when he turns the wheel. You can do it again. Brighton spins the other way. Wheel momentum shifts, so does Brighton. To conserve momentum. That's primarily the main reason why he does it. One more time.
You ever thought about how your lights work, or how your phone works, or just really how electricity works in general? You go down to like a power plant, use the same basic principle, where to generate electricity, you can think of it as like little balls of like current moving along through maybe like a cable or something. Such as like when you plug something into an outlet, you're just allowing those little balls of current or electrons flow into your plug and then flow into your device. The way these are generated are by taking a magnet, such as like one that you might find on your fridge, or you have like one of these horseshoe magnets. I had one when I was younger, it's red. You take it up next to a piece of metal, you rub it against the metal, and it causes the same current that powers lights and your phones to be generated. If you just keep doing that, they kind of do it at power plants, that's how you get electricity at home. Here, we have an example of a tube. In this tube, we're going to drop 2 different things. One will be a non-magnetic item, which maybe it's made plastic or something. But as we saw here, say we place this magnet with plastic and just rub it against metal, it's not going to do anything or create current. So if you want to, drop it in the tube.
Again, this is no magnet.
And this, that came out pretty fast, pretty slick, because there's no current being generated. However, if we swap that instead with a magnet, this magnet, as we discussed earlier, will generate a current. When you do that, it kind of makes it a lot harder to go. You can't just go instantly across as you would with plastic. There's resistance. If we instead of just, like for this example, a flat piece of metal, we wrap that metal all the way around, like in a tube, and drop a magnet through it, we'll see that it's not as smooth as you would expect with plastic. So if you drop it,
It's coming. There you go.
and it comes out, and I caught it though. That was because this current inside, you can kind of think about it through Lenz's law, which is something you might learn in the future. But when you generate this current, those little electron balls kind of become their own magnets, and then they oppose any change that's happening to them. Yeah, and that's it.
All right. All right. So again, electricity and magnetism is something that's around us every single day, but some of us don't stop and notice it. The lights, the outlet, our TV, our phones, pretty much everything that we use in society today runs on electricity and magnetism. And how we're going to show you is kind of an idea of how it works at a basic level. One of the most fundamental things you should know is that there are two types of charges out there, and there's a positive charge and negative charge. So when it comes to electricity, opposite charges attract. So a positive charge is going to go for a negative, and they're going to attract each other. But like charges repel. So on our little sphere right here, this little sphere here is this. So we're going to turn it on, and the belt in the middle is going to start to move. Just how you rub, some of you guys might have done this, and walk around your carpet and rub your sock, or rub your balloon. That little motion creates a charge in itself. So what happens is, all the positive charges go to the top of the sphere. Although I have only drawn it to the outside, it's on all areas of the sphere. And like I said before, positive charges want to attract negative charges. So it'll be looking for anything that's negative on the outside. So it has a little invisible electric field on the outside, and it's getting to look for negative charges. One example, as you can see, is just your hair alone. It starts to pull up. But here's a fun fact. Because Bryden put his hands on here, some of the charge is no longer on the sphere, it's also on top of him. So if I lightly touch him, there's a little shock. Let's turn this up a little more. Alright, here's also the cool thing. Remember how I said that the positive charge stays at the end and summons on Bryden? Here's a cool example. Right now I drop it, these things will stay on there. But as soon as Bryden takes his hands off, watch, and I try to do the same thing, they no longer stay on there. And again, that's because when Bryden had his hand on there, the charge was on top of that and him. Now, it's only on the top. And it's going to repel any other like charges. Whew. The faster this is spinning, the stronger the pull. As you guys can see, the hairs on our... Look at this head. Alright, that's... Yeah, and again, you can't even see the field, but you can feel it. Like right around here is where you start to really feel the electricity. But with the right light, you might actually even be able to see it. So you do it. You might want to zoom in just a little bit. Just turn it off for a confidence second. Alright. Move it to the top so you can see it all around the sphere. It's not just in one spot. What you see there is actually the positive charges moving to the bolt. It has to go through the air itself. As a bolt of light.
What kind of jobs could you get with a physics degree?
So with a physics degree, you can basically become a scientist. As a scientist, you can explore things far out in the galaxy, like stars, black holes, just really anything when you look up into the night sky. Or you could explore really small things that you can't really see, like electrons and electricity and magnetism, or things that make up the universe.
And if you're one of those people that just likes to work with your hands and build things, physics also helps you become an engineer, which depends on you. If you want to build cars, if you want to build buildings, if you want to build electronics, all sorts of those stuff will require you to know some physics for you. So for those of you that like, again, to build things, physics might be a great route for you guys to take.